Hello, I'm Shahbaz Abid. This is General Physics 1 Lecture 7. In this lecture, I'm going to talk about some of the vector operations. Some of the vector operations involve addition, subtraction, and scalar multiplication. In scalar multiplication, if we are going to multiply a vector by any scalar quantity, it's going to change the length, which means it's going to change the magnitude of that vector. If we are going to multiply with a negative scalar quantity, it's going to reverse the direction of that vector as well. In the vector addition and subtraction, there are two methods. One is a graphical method and other is a component method. We are going to discuss these two in this lecture. For a one-dimensional vector, we can simply add them together to give us a resultant vector. So for example, if I have a 10 magnitude vector arrow towards the right, and I have 10 magnitude vector again arrow towards the right, the resultant vector is going to be 20, again is going to be towards the right. If I have 10 magnitude vector towards the right and I have 20 vector towards the left, the resultant of this is going to be 10 towards the left. To understand the concept of resultant, let us see this figure in which we have a reverse bungee. So reverse bungee has a capsule in the middle in which a person sits, and it has two elastic ropes on the left and on the right. Now this elastic rope want to bring this capsule towards the right, and this elastic rope wants to move this capsule towards the left, but the combined effect of these two elastic ropes at the same time is going to produce a motion upward. So this yellow arrow is actually the resultant of these two vectors, and hence the resultant is a combined effect of vectors. Let us see example 1 in which I am going to add the vectors by using graphical method. In this figure we have two vectors, vector A and vector B. Now every vector has a tail and a head. So by using a graphical method, what we have to do is to bring one of the vector tail connecting to the head of the other vector. So basically it's going to be something like this. So I have vector A and I have placed the vector B tail on the head of vector A without changing its orientation and without changing its magnitude, basically also its direction. So I'm just shifting the vector B with the same orientation and with the same magnitude, and the resultant is going to be the starting point, which is here, to the ending of these two vectors. So this resultant, we can calculate it. If we use a ruler, we can get the r value, and even we can get the theta value by using a protractor. We can solve this example the other way around, in which we can bring the vector A towards the vector B, and it's going to give us the same resultant. So in this case, when we are going to add the two vectors, it's commutative, which means the order of terms does not matter. We are going to get the same resultant in the end. Let us see example 2 in which I am going to use graphical method for subtraction of vectors. Let's say we have vector A in the first quadrant and we have vector B in the second quadrant, and I need to find A minus B. So the very first thing we have to do is to change the direction of vector B, because it is actually A minus B. So minus is going to change the direction of vector B, and after that it's going to be the same exact steps as vector addition. So we can bring the vector B tail to the head of vector A, and the starting point till the end of these two is going to give us the resultant, and again we can use a ruler to give us the magnitude of the resultant, and theta is going to be 0 in this case. The subtraction is not commutative, which means order does matter when we are going to subtract any two vectors. Let us see example 3. Which of these vectors have 0 resultant force? And the correct answer is A. If we want to add the red vector to green and then to blue, we can see that there is no distance left from the start till the end, which means there is no resultant magnitude. It's going to be equal to 0. Whereas in all the other options here, we do have a distance from the start to the end by combining the head to the tail of another vector. So for example, if we see this case, we have a starting point here and we have an end point here. So there is going to be a resultant vector something like this. So there is going to be some distance between these two start and the end of the combination of the vectors. The second method in combining the vectors together is a component method. In a component method, what we have to do is to make all the vectors with respect to their x component, their y component, and in the case of 3D with respect to their z components. So we have to sum all the vector component in the x direction, and we have to sum all the vector components in the y direction, and we can basically get the magnitude by taking a square root of rx square plus ry square. In the case of the 3D is going to be rx square plus ry square plus rz square. We can get the magnitude. And lastly, we can get theta by using tan inverse of ry over rx. And in the case of 3D, we can get three angles which are alpha, beta and gamma. These are going to be with respect to x axis, y axis and the z axis. Let us see example 4. Find the resultant and its orientation of the vectors shown. So we have vector A, which is 70 meters, and it is having an orientation of 58 degrees from the positive x-axis. We have vector B, which is 55 meters, and its orientation is 36 degree from the negative x-axis, because we are in the third quadrant in this case. And in the case of vector C, it's having a magnitude of 15 meters and it's moving in the negative y direction. So we have a start here and we have an end here. So there is definitely going to be a vector connecting the start to the end. So vector A has a magnitude of 70 meters and its direction was 58 degrees in the first quadrant. We need to make this magnitude into two components, in the x component and in the y component. Since we are having an angle from the x-axis, is going to be cosine for the x component, and it's going to be sine for the y component, and both of them are going to be positive because this vector has an arrow moving towards the first quadrant. In the case of vector B, we have magnitude of 55 meters and it's 36 degree in the third quadrant, because if you look here, this arrow is basically moving towards the third quadrant. So both of them are going to be negative. The x is going to be negative and the y is also going to be negative. If you want to verify it, you have to basically get the angle from the positive x-axis. So it's going to be 180 plus 36 is going to give you both of the answers negative again. But if you are sure that it's a third quadrant, you can directly substitute the x and the y component to be negative. But if we are using 180 plus 36 degree, you don't need to substitute a negative value. The answer is going to make it negative. The vector c has a magnitude of 15 meters and its direction is in the y-axis, so its x component is going to be 0. So the whole magnitude is in the y direction, moving downward, so it's going to be negative 15. We have to sum all the rx, will give you minus 7.41, and we have to sum all the ry, is going to give us 12.03. Now we have a positive y and a negative x, which means we are in a second quadrant. So r is going to be square root of rx square plus ry square. We are going to get the magnitude of the resultant vector is going to be 14.13 meters, whereas the theta is going to be tan inverse of ry over rx, is going to be minus 58.4 degree. Now why is it minus 58.4 degree? Because the angle is going to be taken from the negative x-axis and it's going to be a clockwise angle. So whenever we have a negative angle, it means it's a clockwise angle. And if we want to get the angle with respect to the positive x-axis, we have to basically do what is 180 minus 58.4 is going to give us the angle from the positive x-axis. Let's see example 5. Find the force F3 and its orientation from the positive x-axis, which make the resultant of these forces equal to 0. So we have two forces acting here. One is F1, 80 newtons, and it's going to have an angle of 55 degrees from the negative x-axis, whereas F2 is 40 newtons and its angle is created from the positive y-axis, which is 55 degrees. We need to find the F3 magnitude as well as its orientation, which is going to cancel out the resultant of these vectors. So we have vector F1, which has a magnitude of 80 and its direction is 55 degrees from the negative x-axis. So we can now see that it's in the third quadrant, so both of the resultant component is going to be negative, rx is going to be negative, and it's creating an angle from the x-axis. So the x-axis is going to have cosine and the y is going to have sine. So we are going to get the answer as minus 45.89 and minus 65.53 newtons. For the F2, we have 40 Newton magnitude and its direction is 55 degree, but the angle is created from the positive y-axis. So now y-axis component is going to be cosine and the x-axis component is going to be sine. Since it's in the second quadrant, we have y component to be positive and the x component is going to be negative, whereas the F3 is unknown, its direction theta is also unknown, and I don't know its x component and also its y component. So we can just sum all the rx. We are going to get F3x minus 78.66 and we get the ry summation to be F3y minus 42.59. Since the resultant of these forces must be 0, so we can say that Rx is equal to 0 and Ry is also equal to 0. So we have the left hand side equal to 0 and the right hand side is basically x component is F3x minus 78.66 and y component is F3y minus 42.59. We have on the left side equal to 0, so we can just get the F3x and then the F3y. Once we get these two, we can now simply calculate its magnitude as well as the orientation of this vector or this force F3, which will cancel the resultant and it's going to make the resultant equal to 0. Since we discussed how we can get the components of the vector if we know the magnitude of the vector as well as its direction with respect to any axis. Now if we know the components already, we can get the resultant from the components, but to express the components of that vector we have to introduce a unit vector. Now a unit vector is actually just having a magnitude of 1, but it is just going to tell us in which direction is that number or is that component is. So I is basically the unit vector in the x direction, j is the unit vector in the positive y direction, and k is the vector in the positive z direction if it's a 3D case. So we can express any vector with respect to its component as some number I plus some number j, whereas in the case of the 3D is going to be some number times I plus some number times j plus some number times k. Now we can get the resultant is going to be rxi plus ryj. So if we want to add any two vectors, we have to add the I of one vector to the I of another vector. We cannot add the I to the j. We have to add all the i's together and all the j's together. Okay, that is going to give us rx and ry. In the case of the 3D, we have to add all the k components of that vector. So we can get the resultant now. It's going to be again the same way, rx square plus ry square whole root in the case of 2D. In the case of 3D, we are going to have rz square as well. And the direction, we can again get it as ry over rx. In the case of 3D is going to be alpha, beta and gamma. Let's see example 6. Two forces are applied on an object. One is F1 is equal to minus 10I plus 20j. Now this is vector components in the I direction, which is x axis, and in the j direction, which is plus y axis. Whereas F2 is equal to 10I plus 25j newtons. What is the magnitude of the resultant force in Newton acting on the object? So to get the resultant, when we know the components of that vector, it's going to be summation of all the I values together and summation of all the j values or components together. We are going to get in this case 0I plus 45j. And if I want to calculate its magnitude, it's going to be rx square plus ry square whole root will give us 45 Newton, which means what? That the resultant is going to act in the positive y direction. It's not going to have any value in the x direction. So it's going to be just in the positive y direction. Thank you, and I will see you in the next lecture.